want to share with you how I say I'm the Vice President of Sales and Marketing of Hazard Control Technology. Hazard Control Technology is in Fayetteville, Georgia. Our mission is try to share the acknowledgement of the Encapsulator technology with all of you and with more of the people all around the world. We have a lot of friends today in this meeting from Australia, South Africa, different states of USA, people from Brazil, Canada, and this is, for us, is wonderful. Try to share with all of you this amazing technology. We have locations, like I mentioned before, all around the world. We have office, our headquarters here in Fayetteville, Georgia, but we have an office in Sao Paulo, Brazil, Frankfurt, Germany, Australia, Asia, in Nigeria. Our company work in different ways. We work in the municipal fire service. We teach a lot of fire department with this technology. In this case, that today we try to talk about the sprinkler system. We participate in different committees, people of our company, and we participate in different society and different associations, especially the Society of Fire Protection Engineers. We try to share with all these folks how they can start to use the encapsulator technology with the different hazards that they have to manage in the different industry. How I mentioned in the beginning of my conversation, this is a new technology. See, we are not so new. We start to work 25 years ago, and the idea, more we try this product, more we test this product, we understand very well that's how the new technologies are working. We start to have more hazards in the different markets. We start to test, we start to understand that with this technology, we can address these different hazards. An example and is more of the special hazard that we have is lithium battery fires, three-dimensional fires, class D metal like magnesium, titanium, zirconium, different class of metal, and especially the green energy, solar panel, wind energy. We start to test with different companies in Europe, here in USA, but we start to receive from other labs, from third-party labs, that they are testing our technology, and they are making different comparison with water, CO2, dry powder. And the idea of today is try to share with you how you can use this solution in the fire sprinkler and how you can understand the other agent, how they can work in the different way of our technology. Today, we try to understand what is the encapsulator agent, the features of this technology, the application of the encapsulator agents, how we use the fixed systems in different applications, and different examples and projects that we will try to share, and some tests that we made in the past in different locations. Today, we will use an example that maybe can be, the example is one in the mattress company in Panama. The objective of today is try to understand the difference between these two technology, the foam technology and the encapsulator technology, how we can explain that you can understand very well the different characteristics of the encapsulator technology and the different application, and how we can identify in the industry and in the different emergency where we can use this encapsulator technology. To start, I want to share
the old and familiar
this
representation of a fire triangle has been replaced with a fire tetrahedron because we now know and recognize a fourth element crucial to combustion, a chemical chain reaction. The four sides of a tetrahedron represent the four components of fire.
The idea of this video is try to share with you the four parts of the fire. See, more we understand how work the fire, we can understand how we can apply and what part of the fire we can use with one of the features of this agent.
Heat, fuel, oxidizing agent,
and
the chemical chain reaction. If any one or more of these components are absent, a fire cannot occur. When all four components are present, heat, fuel, oxidizing agent, and the chemical chain reaction, fire will occur. There are four options for extinguishment: cut off oxygen, cut off fuel supply, thermal insulation of the fuel, and interruption of the chemical chain reaction. When one or more of the components are removed, the flame goes out.
The important thing of this video is to understand when the person said that if you move one of the components, the fire is out. With this technology, we can attack each component in the same time. And how we can use these four components, how we can attack these four components with the other normal agents, that is water, foam, and how we can use the encapsulator agent. If you use water, see, you will attack, you try to reduce the heat. See? But the problem of the water, that when you attack the fire, you will take, you convert from the water on steam. This conversion takes from the fire that you have an idea, 6,600,000 kilocalories, okay, with the water. But you not only use all the droplet of water, you use the part of the droplet that touch the fire. See, they take the heat, they convert in steam, but the other side of the droplet you don't use. It's not so efficient to reduce the heat. Yeah? The other agent that's the people use a lot in the fire sprinkler is foam. See, foam is a technology that you create a bubble. Yes, it's based on bubbles. You need the agent, you need water, you need air to create this bubble. When you create a bubble, you create a blanket to put on the top of the fuel to separate the oxygen, yes, of the fuel. But you only are working between the fuel and the oxygen, try to separate the oxygen of the fuel. But the problem, when you create these blankets, you don't reduce the heat. The heat is below the blanket. If you have any problem and somebody broke the blanket of foam, you start to have vapors, and how you have temperature, these vapors start to burn again. This is two different ways in this agent. Water take and reduce temperature, foam separate the oxygen from the fuel. But the encapsulator agents, it's other different technology, because we reduce faster than water the temperature, and that you can understand. You remember that I mentioned that the water take from the water 6,600,000 kilocalories per hour. When you put in the dropper, you put on a skin of this agent that I show you in the next slide, you will take from the fire 21,600,000 kilocalories per hour, almost 3 times more than the water. Yeah? But the problem with the water, that's you have a smoke, you create steam, and the steam is hot. Here, you decrease the temperature, and you maintain the temperature so level that you don't create smoke. And this smoke, you decrease the visibility. Sorry, you increase the visibility and you decrease the toxicity in the same time, because this agent attack the encapsulated hydrocarbons. He attacked the fuel, but he attacked the free radicals in the chemical reaction. This is why you decrease the toxicity of the smoke and the soot. And the other part, when you encapsulate the fuels, in a molecular level, you are working to separate the oxygen. In this way, you can understand that with water, we attack the temperature, with foam, we attack the oxygen, but with this agent, we can attack the 4 legs of the fire tetrahedron. To understand better how work this different technology, the wetting agent, yes, that's they download the surface tension reduction of the water. They create a lot of steam. Yeah? They convert a water, take the temperature, and create a lot of steam. Foam, like I mentioned, they create a blanket of bubbles, and the encapsulator agent that's it's mentioned in NFPA 18A. The foam is mentioned in the NFPA 11. The encapsulator agent work in these different levels in the fire. The other most important thing that has this agent that decrease the surface tension reduction and has a lot of enter inside of the fuels very, very deep. In the encapsulation way, you can see in the other slides that this agent converts fuels and vapor in no renders fuels. See that when you encapsulate the fuels, you cannot burn the fuel or the vapors. To understand better, we try to understand what is an encapsulator agent. We mentioned before, when you work with foam, the basic building block of the foam is the bubbles. Here, this is a different technology. The encapsulator agent is basic building block on spherical micelles. What means? That these spherical micelles are capable of encapsulate carbon molecules, both polar and non-polar molecules, hydrocarbons, and you can encapsulate not only liquid, you can encapsulate vapors. This is why you not only can focus on the fire, you can focus to prevent the fires when the vapors start in the middle of some ignition, of you have some spill or you have some problem and you start to have vapors. This is why these two different technologies that you can use before start the fire. And I mentioned before that the new standard about the encapsulator agent, this product was created for our company in 1996. This product is effective for class A, class B. We have this product has UL in the NFPA 18 in class A and class B fire, but in the same token, you can use for class D fire, that is metal fire, on lithium battery fires, and you can use in different kind of fuels, like polar and non-polar fuels. With foam, you have to understand that how is your hazard, how is the fuel? Because if you have a non-polar fuel, you have to use a foam that is resistant, like AR, AFFF, that's the alcohol resistant foam. And the other product, you have to use the AFFF. In this case, you don't have this problem because you can use the same product, the same encapsulator technology, for these two different fuels. The other thing that I want to share, that this standard, it's so new because in the new standard of NFPA 18A, the new standard started in January of this year. The important thing of this new standard, that in this standard you can find different sections where you will have how is the section that is the NFPA 18A section 77, where you can find how is the test of the spherical micelle stability test, to understand this is the test to pass and not pass if your product is an encapsulator agent. Yes. In the same standard, we will talk in other slide. We have in the section 12 how you can use this product like supporting guidelines in the different hazard, in the different classes of fires, and how you can use with manual fire extinguisher, and how you can use in the fixed installations this product, how you can use the NFPA 13 and the other NFPA, how you can use to put this technology inside of the fixed system. Yeah? To understand how work this product, this is a video that you can understand better how is the encapsulator agent.
Encapsulator Technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting.
Here you have the version of, this is a nanomolecular level. The agent is so small that if you make a comparison, the droplet of the water, you can imagine that is the size of the air, our world, and this molecular level is like a corn. See, it's very small. When you want to put inside of the water, you can see now how one droplet have millions and millions of this molecular. This molecular has two parts. One is the head of the molecular that loves the water, and the other, the tail, hate the water but have a better connection with hydrocarbons and all the products that have carbon in his composition. This is why it's so important to understand, because if you focus not only on the fire, if you focus to prevent hazard for the first responder, for the firefighters, and to prevent cancer, to prevent some issues in the health of the firefighters, this part, the tail of this agent, you can use to decrease the toxicity of the smoke.
Of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic non-polar tail which fears water and will do anything to get away from water. Once the EA molecules.
Here, you can see that you can use a proportional like you use with foam. Yeah? But this kind of agent, if you don't have proportional, that we have some issues in South America, in different fire departments, because they don't have this equipment, you can put this agent inside of the tank and premix. Yes, we have a test in our company more than 4 years that premix with water has the same effect these 4 years and don't have any problem to extinguish a fire or to pass the test of NFPA 18A section 77. Here you can see how enter the agent on the water, and you can see how the molecules start to work on the water.
The EA molecules enter the water. They instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles.
Here is how this technology starts to be different, because this tail don't love water, and here in the pipes, in the hose, all the tails will be inside of the micelle. But see what occur when start to be in the line, in the nozzles or in the sprinkler, how this tail turn to outside of the droplet.
Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet.
This is how I mentioned before. This is the fantastic thing of this technology. How the tails hate the water when they take off of the nozzles of the first sprinkler, they turn. And the most important thing that you have to understand that these tails are looking for carbons and hydrocarbons. See, when you see this, and you can see the skin of all these billions of molecular polar head on the nozzles, on the droplet of water. This is why when you use to decrease the temperature, you put the temperature, and this million of polar head creates the thermal convection. So they start to pass one to other heads very fast, and you start to use this droplet of water more effective without this agent. This is why when you start to test, we start to use this product in different sprinkler systems. This is when you have water, and we test in some part with 1,000 liters of water, we cannot extinguish the fire. And when we use this skin of this product, like you see here, and we use to extinguish the same fire, we only use 50 liters of product to extinguish the same fire. We use 1,000, we can, but how we can make this? With this feature, see? That we can use all the droplet of water. We can start to be more effective with the same quantity or less quantity of water.
In addition to the EA skin, there are millions of molecular spherical micelles within each droplet. Encapsulate.
Okay, this is how I can share the slide before. This is the comparison of a drop of water, and this is the comparison of one molecular of A500. Remember that you have to create with this and a skin all around the hair. This is why when you have a drop of water, you have billion of this molecular. When you start to work with class D, with metal fire, now you can understand, because more of us, when we start to work like firefighter, like fire protection designer, all the time say, never have to use water in class D fire, on metal fire, because you start to have spark, you have to have some problem. In this case, you put a skin of millions of this molecular that you can prevent the water touch the metal, and you can be more effective with the water to decrease the temperature on metals, or especially on lithium batteries. And now that you can understand the feature of this technology, that we start to talk about the different features that this technology has. The first is the encapsulation, that this agent can encapsulate fuel, rendering extinguishes objects and non-flammable products. Yeah? Why we create this is the same, like I explained, with the tail. They are looking for hydrocarbons and they try to create a cocoon inside the hydrocarbons and prevent that the vapor start to take off of the cocoon. When you have some place to protect and you have different material inside of warehouse, you have class A fire, you have class B fire, you have different class of fuels. You can have diesel, you can have gasoline, you can have alcohol. Is an example in a warehouse of like Home Depot, Walmart. You have lithium battery inside of this huge warehouse. You don't have to use different agents for the different products that you have inside of the warehouse. You can use the same agent for all these hazards, not only water, because water you can use maybe for class A fire, but you cannot work very well in the different fuels. This is why when you start to understand the different feature of this agent, you can understand how you can apply. In this case, this feature can help you to encapsulate all the vapors of the fuel and prevent fire. If you have some hot product, if you have some spark, to prevent the fire and start the fire inside of some of this storage. For this, the test that you have to pass is the NFPA 18A section 77, that is the spherical micelle stability test. The other feature that, sorry, we have this is the test that you have to put one part of the additive, 8 part of fuel, and 40 part of water, plus kinetic energy. This is the test that we have to make.
Here we're demonstrating the NFPA 18A section 77.
Touches, please. Can you turn off the microphone?
Test. In that test, you take your test fuel, which could be any fuel, in this case gasoline, it could be heptane, alcohol,
here,
ethanol.
you can see
pouring in 1 gallon of
Mr.
the fuel into the test can.
Is putting in the pan log a part of gasoline.
16 ounces.
Here he is putting 1 part
Encapsulator Agent
of
being
additive.
tested.
Yes, of encapsulator agent.
And here, using a calibrated 5 gallon per minute nozzle, we're going to add 5 gallons.
He will measure the time to put 40 parts of water with kinetic energy. See, please, the kinetic energy that you need to mix this agent and encapsulate the fuel. It's not a lot of kinetic energy, but it's a point that you have to understand. Without kinetic energy, you cannot mix, you cannot encapsulate the fuel. This is why if you have a pump, when this agent pass on the pump, is the kinetic energy that you need to mix the water with the A500 and create these missiles to spray in the sprinkler and use in the different hazards. I move forward the video. Okay. The test said that you have to, when you encapsulate in 1 minute, you have to pass the torch on the top of the paint log to try to burn the vapors.
And then we come by and we to the
He's waiting for 1 minute.
surface of this mixture.
I try to move forward. 1 minute after,
So
he
after
tried to
1
burn.
minute, we can see we have a
He-
heat here.
He's showing that's
We apply
he's
this
working
to
the
top
torch.
surface of the mixture, go all around.
He passed the torch on the top of the pine log.
We shouldn't see any flammability.
A lot of people say me, yeah, but we don't see the flames. This is, if you see here, that's he's using the torch to see that's we use in the flame. Okay? We have flames. You can see in the video, but we use the flame. I move forward to move. I want to say that some wetting agent can be passed this first minute because they create a wonderful maybe blanket of bubbles. But the test said that you have to return 2 hours later and you have to pass again the torch on the vapors, on the top of this solution. Yeah? If you use other technology, how the blanket of foam, when the tank is running, this blanket starts to decrease. The bubbles start to decrease. This is when we start to have vapors. In this case, you don't have vapor because all the fuel, see, now we can see the flame. We cannot see the vapor, we cannot burn the vapor because we encapsulate all the fuels in this test. We have a way to separate, yes, we have a way to separate the fuel from this solution. But in this case, when you have an spill and you want to use this technology, you cannot separate in this like the other agent. If you put your foot on the foam, you can separate these bubbles and you can have vapors. In this case, if you put your foot inside of the solution, you cannot separate the solution with the fuel. See, this is, for me, is more important, this kind of agent, to prevent accidents in the fire, in the firefighter service with the fire brigade, because you can encapsulate the vapors and you can prevent some incident in the middle of the fire, in the middle of an accident that you are working in a car fire and you have some spill. If some spark touch the gasoline, can burn. In this case, you can use to prevent the spill, to prevent the vapors, and you can work easily to take off from the car, or you can extricate the person from the car. For us, in this kind of, to use in the fire sprinkler, we can use this to encapsulate the gasoline or the vapors, and we can prevent any ignition on different parts of the warehouse of the place that we want to protect. The other feature for me is more important feature is how this agent can reduce the toxins in the fire, including, if you pay attention, hydrogen fluoride. Why we put here hydrogen fluoride? I don't know if I mentioned very well, but this is the product that we have when we have a fire on lithium batteries. This fluoride, hydrogen fluoride, is very toxic for the first responder. If the people want to use to extinguish a fire, they will breathe this quantity of gases, and these gases are very poisonous. Yes. Only to share with you, you can be exposed 90 parts per billion in 10 minutes. You cannot be exposed this part, 95 part per million in 10 minutes. If you use water, you can be exposed to this fire from 200 part per million to 2,000 part per million. This is why if you have a fire in a warehouse where you have fuels, where you have class A fire, where you have lithium batteries, and the lithium batteries start to burn, in the same fire you will have a lot of black smoke with the toxicity of the smoke, that you have different hazard in the smoke that can create cancer for the firefighter. And with these gases, if you have in the same fire lithium battery, you can be exposed for this class of gases and you can be in danger. To show you, in the 90s, the Clemson University created a study and they made this burning toluene. They use water and A500 at 3%. They try to measure the smoke, the soot accumulation, see here, and the toxicity in the smoke. When they finally finished, they sent these two samples of soot to two different labs to understand what kind of toxicity product we have inside of the soot, and what is the toxicity of the smoke too. What they found when they finished this test, they can understand that this agent can increase the visibility in the fire, decrease the soot 97%, and 98% reduce the toxicity of the smoke. How you can use this with a fire sprinkler? You can use this to prevent some issues in the health of the people. If you have a warehouse like Walmart or like Home Depot, and you burn, you have a problem of huge fire inside of the warehouse, with this sprinkler, with this agent, you can prevent and you can increase the visibility inside of the fire to try to understand where is the fire. You can decrease the toxicity of the smoke, and you can prevent some issues in the health of the customer inside of the room or inside of the shop. Yes, this is why you not only can use this agent with the fire sprinkler to stop the propagation, you can use this kind of agent to decrease the toxicity of the smoke and increase the visibility when the firefighter arrives, and they can understand where is the fire, and they can stop the fire and kill the fire immediately. The other feature that for me is important, that's this agent, how this agent don't need to create bubbles. You don't need to have fluor. When you see, we will see now in some video here, it's like milk, but you don't have any bubbles. See, the most important thing that we have a huge issue here in USA. That's a lot of different agents have PFOA, PFOS, and start to contaminate lakes, grounds, different states like Michigan, North Carolina, in USA, they start to find this inside of the fish, inside of the animals, inside of the blood of some person. This is why, talking about environmental issues, when you use this product, how I mentioned that you increase the effectivity of the water. You start to use less water. You start to have less runoff of water. You don't spray a lot of quantity of amount of water, and you don't attack. You can use this without any problem to put this fluorine contaminant or agent on the legs. Yes, because this technology don't have any of these fluorines in his compositions. Now, I want to start to share with you the different application. For this, I want to share this video where you can see the different application where you can use this technology, and especially with the different in the different sprinkler system, in the different deluge system.
Hazard.
Here we start with a class A fire with pallets. The pallets on the left, we pre-treat with 1% of product. We burn 3 minutes, 5 minutes, and see nothing, and in very fast you extinct with the class A fire. See, with this is tires. See the smoke. In seconds, you can decrease the toxicity. Here, you have a car fire with a magnesium inside. Use the quantity of agent that you can use. See? And you extinct with the fire. This is a class B fire, it's a DC fire, and it's different like other agent because you have to move. You have to encapsulate. Here is ethanol. If you see the firefighter, he's walking on the agent. If you use foam, you cannot walk on the foam because you start to brown and start to have vapor. Here is a three-dimensional fire. Here he's cooling the metal and he's encapsulation the fuel. This is propane, three-dimensional fire. See, he encapsulates and is more safe to the people that close the valve. Here is a lithium battery. On Netherlands, this is the lab of Kiwa. This person have some problem in his head because he don't use SCBA, and these gases he finished to go to the hospital. This is magnesium, and when you test with magnesium, believe me, here when you finish to extinct with the magnesium and you touch, is how you take off from the refrigerator this, and maybe this temperature is more than 1,200 Fahrenheit. Here is a fire of transformers. This is a three-dimensional fire that you have metal. You can cool the metal and you can encapsulate the fuel that you have inside. And this is how you can use in different agents. And where we can use this technology and how we can use this technology. See? We can use with bladder tank, we can use with water drip proportional. This is the way how we can apply. See, we have to be careful because some customers said, "Oh, okay, I have a bladder tank in my company with foam. We can replace this bladder and we can use the same bladder tank." It's a problem, yeah? Because if you understand that this technology encapsulates the hydrocarbons, this bladder of foam, they have glue around based on hydrocarbons. If you use the same bladder, this agent starts to encapsulate the glue, and when the tank is moving in a few days, this bladder starts to leak. And when you need the bladder tank to squeeze the bladder, you will not have agent inside of the bladder. We have the solution, yes, of course. You can replace the bladder. You can use the tank, but you have to replace the bladder inside, and you have to put a full bladder that you can use with this technology. Yeah? Let me share with you in these days we use. We can use in warehouse, we can apply in airport hangars, in distribution centers. We can use, this is a project of Goodyear a few years ago. This is the project that's, this is a rubber tire storage. The configuration was approximately 19 feet. And according to the NFPA standard, the codes require a sprinkler discharge density no less than 0.6 gallon per minute per square foot for this tire storage height from 5 feet to 20 feet of height. Yeah? In this project, the existing sprinkler system was designed and installed per this requirement. What was the solution that our company proposed to this customer and the fire department that control this facility? Using the A500, we demonstrate that the fire suppression agent can be more effective on rubber tires that foam. Yes, and you can have a faster knockdown, better heat reduction, better burn ban resistance, and we propose to use the A500 in the existing sprinkler system. The idea of them is change to this sprinkler system, to put more water, and in conjunction with the A500 with this sprinkler, it was not a conflict to use the A500. And we don't have to replace the sprinkler heads. We can use the existing sprinkler head, because when you use and you see the viscosity of our product, is the same that you create a designer with water, with the NFPA 13. The other thing that we can work in this with the A500, if you use foam, you have a problem. When you spray the foam, you have the cost to clean the foam. But with this A500, you not only can use for steam with the tire, because when the tires are burning, they start to burn and they start to leak like oil. You not only can encapsulate the vapors, the smoke, you can encapsulate this oil that the tire create when they burn. See? And you can use for Class A fire, and you can encapsulate this liquid when you have a fire. And when you use the product, you don't need to clean because it's environmental friendly. If you have this on the ground, the same bacteria will eat this liquid inside of the micelle of the cocoon. Okay? And you don't need to take off of the ground like maybe you have to make this with foam. We can increase, in this case, with the same fire sprinkler, the sprinkler system with A500, we can increase on 25% from 900,000 tires to 1,200,000 tires with the same sprinkler system. See? Let me share with you this video, because we have this project was in the 90, maybe 2000, but a few years ago, we have the same issue in Panama, yes? And we have a mattress company in Panama that they want to have a project, and the fire department want to use water, and they say that they have to use 90,000 of gallons of water. Let me share with you this project. That's in a moment. This is the video that I want to share with you, because it's the same project like the tires, but it's about other kind of fire. This is the Canal of Panama. This is the owner of the companies. Okay? This is the mattress that we burn to test, because And here you can see that we use two different totes of 1,000 liters of water and 1,000 of liters of this solution at 1%. What was the difference with water and this agent? We use the water with a density of 0.4, and we use the solution of 1%, the density 0.2. Yeah? Less density, less the size of the pipe is less than water. See how we manage this? We test first water, and we have all the fire department that they want to use 90,000 gallons of water, and we try to show them that this is different. This mattress burns from inside of the mattress. This is why we try to create like a real fire, and we put gasoline inside of the mattress. I burn the mattress here. See, we have a window. Where is the camera? We have other door that we close, and in the screen, in the left of the screen, you have other door that we close. See, on the top of the mattress here, we have two heads of a sprinkler. Okay? We leave burn a few minutes. Let me move forward. Here, see, we burn. On the top is A500, on the bottom is with water. See, and when the numbers start to move, it's when we start to use the sprinkler. Now, we leave burn, and now we start to use this pump to use the sprinkler, two heads of sprinkler. See the velocity, how it start to decrease the flames with the 500. See, in 15 seconds, you almost don't have flame, but in 20 seconds, we extinguish the fire. We leave 1 minute, run the sprinkler system. And in this other 40 seconds, the temperature starts to decrease inside of the room. And the toxicity, you can smell the toxicity, you can smell the product inside of the room. With the water, see, you can start to have visibility inside. With the water, remember that we have double of density here with water. See, I move forward, see, I move forward. In 1 minute, 40 seconds, if you can see it on the bottom, the fire department start to smell. Oh, they don't feel the toxicity of the smoke. I enter in less than 2 minutes. I enter with my bunker gear, but close of me there are a firefighter with a short shirt. He can enter because we don't have temperature. See, they put the hand inside. They start to enter, to test, to touch the mattress. If you can see, still running the sprinkler in the bottom with water. See, 2 minutes. I move forward. See, the people start to enter, to touch the mattress. If you understand now how we can use this, the different features to use here. See, when the 1,000 liters of water finish, see, here, finish the water, we have to enter with a fire hose to extinguish the fire and to push the vapors outside and to decrease the temperature to enter. We use 4 minutes 34 seconds. And with the 1% solution, we use only 20 seconds. We use 1,000 liters of water at 0.4 density, and we can extinguish the fire. And we use 0.2 of solution at 1%, and we only spend 50 liters of agent, or solution, sorry. This is when the fire department understand, they approve from 90,000 liters of water, they approve to use 30,000 liters of solution to protect the company. Because they can understand that the water can be more effective with less pipe, with less side of the pump, but with this agent at 1%. This is when I start this conversation, I say, guys, more you test, more you understand this technology, you start to understand that how you can protect different facility with different hazards. This is a problem we start to have or to know with a people that's
the huge flames erupting at a Pepsi-Cola factory.
Sorry. Here. I have an issue with the PowerPoint thing. Here, with the phone, with the
huge flames erupting at a Pepsi-Cola factory.
Only Newscopter 7 has pictures like this. The fire in the Middlesex County township of Piscataway.
Millions of dollars to prevent this and to clean with foam. Yeah? This using hangars, and now the NFPA about hangar, they are looking for a new solution to protect three-dimensional fire, and they start to understand that there are a new standard NFPA 18A in the section A, in the Annex A 0.4.3 that said that now you can use this encapsulator technology for lithium batteries. This is why in the hangars, they start to try to understand how they can use for three-dimensional fire. Here, we have
Eyewitness reporter Josh Under live at the scene with new information we just got moments ago from the mayor. Josh.
That they are not
things have finally calmed down here at this PepsiCo bottling facility behind me, but wow, it was a different story over the last several hours. We can go back to that video from Newscopter 7 as it was fully engulfed. It started just before 7 o'clock this evening. Township officials tell me that the flames started on the outside of the building, climbed up one of the walls, and then...
Hernan, you have to turn the video sound down if we're going to hear you, because we can't hear you.
Okay, thank you, Mike. Here in the video, in this video, we want to share with you how this huge structure, huge warehouse, they use a lot of water for many, many hours. And the problem of the water that is not effective in this huge fire. This is why when you start to have this huge fire, you have to understand that now you have other solutions. The other fire on the right is the Walmart fire a few weeks ago. See the smoke, see the toxicity of the smoke. If you follow the news, all the city around of this fire start to have some health issues about the smoke. And the problem, if you want to protect this for your company, if you want to put some sprinkler, the sprinkler system didn't work. Because again, in this kind of warehouse, you have different fuels, polar, non-polar fuels. You have lithium batteries. You have class A fire. You have three-dimensional fire. Because you have different racks, and this is a three-dimensional fire. The water cannot be effective. And the other thing, with water, you cannot prevent this toxicity smoke, especially not for the firefighter only, for all the community around of this location. This is why when you start to understand how you can use this new technology, not only thinking on the fire, thinking to stop the propagation, to use to be more effective to use less water, and when the firefighter arrives, and you have this agent to increase the visibility, the firefighter can enter inside of this warehouse, can find where is the fire, and they can extinguish the fire faster. This is why we don't have to understand that it's only okay to replace water, to replace phone. No, we have to use this to be more effective, to protect the different facilities. We have the tool now. The only thing that we have to know how we have to apply, how we can use our standards, NFPA 13 with NFPA 18A, section 12, in the different classification of fire. If we have a class B fire, we can use this technology. If we have a lithium battery, we can use the same technology. If we have a polar fuel, we can use the same technology. But we don't need looking for magic solution. We have the solution. And this is one of the way that we can use, and it's not a new technology. See, this is the bladder tank that's normally in the past we use a lot in different hazards, especially in the cold hazards here in USA. We have the bladder tank here, we have different valves, the water enter, squish the bladder here, and we have to the sprinkler the solution that's we can protect the different place. Here is a picture of all the deluge note, the piping, the bladder tank on behind here. Okay? And this is some examples that we use to protect transfer point, okay? To protect conveying system, to protect silos, to protect transfer house, crusher house, reclaim tunnel, trains. Here, rain and load buildings is the building that they turn the train of the train, they turn the trucks with coal, and we protect this to encapsulate this solution to enter inside of the coal and prevent the fires. This is other solution in other power companies with coal, see? And we have some of this bladder tank to protect some warehouse, to protect different lithium batteries, energy storage. But now the future is with this technology. Simple, easy to protect, easy to use, easy to install, the water-driven proportional system. How work? This is our diamond dozen powered by fire mix. And if you see this video, you can understand that it's more simple. You have one part where, oh, how work this? It's very easy. This is a video that you can understand this equipment, that is the water-driven proportional. How we can use this, and believe me, is so different, is so effective, and is so easy to understand and to install, different to the bladder tank. Yes, it's two different applications, two different ways to use on the deluge system, on the sprinkler system. How we can use this? We can put the pipe here of water, and here, see, this is the pipe of water. When the water runs on the pipe, and this is closed, this can go to some monitor, to fire hose. But when you open, this is, you can use with water. But when you open the valve, that the water can pass from the water-driven proportional, this is the tank of the agent. Diamond dozen is special for encapsulator technology. This is how you can use. When enter you can apply the product. More water you use, you can apply and you can measure the quantity, 1%, 3%. Remember that we use 1% for class A fire, and we use 3% for class B fire, for metal fire, for lithium battery. When you use this is for cleaning the water treatment proportional. When you open, you can use this, and we need measure how many hours you need. We can use for multiple applications. We have solution flow. You don't need power for this. We don't need huge quantity of agent. And this is, the expense of this is an economical investment to protect your facility in an easy way, and especially when the maintenance of this equipment is less than when you use bladder tanks. These some examples. This is on silo to wash. This is a tote. This is a water rate proportional. This is the riser. This is a energy company. And now we can see some example of protection on three-dimensional fire, on three-dimensional class B fire protection. This is under turbine lube oil system. If you see, in this type of protection, the water where the NFPA 850 said you have to specify sprinkler application density to protect this, the water is not effective on class B fire. In this kind of hazard, we have a turbine, but the turbine have oils around, and they have oil under pressure. When you have a problem and some of the pipe broke, this oil start to be with a high pressure and start to burn. The problem of the water that you can cool, but you cannot use on this oil under pressure. The foam don't work for class A or class B in this case. Why? Because the foam here in the NFPA 11, in the Annex A.1.1 said that foam is not suitable for three-dimensional fire and fires under pressure. Yes, this is why, to understand, we have to create a bubbles. We have to create a blanket of bubbles. If we have pressure, if we have a three-dimensional fire, you have to use all the blankets to put under the blanket this huge transformer, this huge under turbine lube oil. It's not practice in the real world. Yes, and if you have some problem with the high pressure, they broke the bubbles and you will have again a new fire. This is why this market start to use Encapsulator Agent. Why? Because they download rapid and permanent, reduce the temperature. They start to encapsulate the fuels. They don't need to create remember, they don't need bubbles. They encapsulate this oil on high pressure, and you can use this for three-dimensional fire. This is a fire protection under this hazard, under turbine lube oils. Factory Mutual said that you have to use this in this density, 0.4 gallon per minute, per minutes for square meters. They say that you have to protect this. In the past, we have a company that is Dominion that they call the insurance company and say, hey, we don't want to change all our sprinkler system because you say that we have to use this density 0.4. We use an agent that we know works, and they make a test with the factory mutual insurance company, and they try to use to upgrade not to 0.4, to upgrade the sprinkler system to 0.3. They have some issues, but they try to explain the insurance company how they can use. And here you can see in the pictures the people of the Dominion company, the people of our company, the people of Factory Mutual company. They are working to create a test like they find in a under turbine lube oil fire. See, and they test 0.15, 0.20, 0.30, and 0.40. This is the video 0.20. This was in 2010. I see. Okay. Let me see, because I have a here. Here it is. This is the test that they made with the A500. See here, we pre-burn for this temperature, 1100 Fahrenheit to 1300 Fahrenheit, and we use the encapsulator technology in the density 0.2, and with water we use 0.4, the same density that we use in the mattress, remember? But see how work in this kind of fire. They test, they burn,
10, 11, 10.
The metal around, when this oil burn, start to heat so hot. This is why when you see the water, you understand, okay, we can extinguish very fast. No, because the temperature of the metal, they cannot decrease the temperature. With this product, with the encapsulator technology, you decrease the temperature and you encapsulate the vapors. Two different features in the same time. This is why you can encapsulate and you can extinguish the fire in 11 seconds. And the other, with the double of density, you use 3 more water, or you extinguish 3 more times. See, this is the drawing with this quantity of density. They use this time, 11 seconds, and they use with water, they can extinguish more, almost 2 minutes. They can show to the insurance company, say, guys, if you understand how works this technology, we will be more protective. Our fire, our sprinkler system can be more effective than only with water in the density 0.4. This is why the test, the result of the test, FM Global understand that with A500 is 3 times faster to extinguish the fire with the double of density with water. The company understand that with this quantity, this density, they can reduce the heat, and the performance of the sprinkler system is better, and the company feel comfortable to protect each facility with this solution. This is why FM Global understand that this is a better protection for each facility. This is an example in different part of this company that we use a bladder tank to protect, see, transformer and turbine under their protection. We use this in Virginia for the same. This is under turbine lube oil. And this is other protection that we use is for transformer, 3-dimensional fire. If you see, this is the issue about the transformers. See, let me move forward with, a lot of transformers are so old and they start to have some issues. See, this is the fire we can find in the transformer. Fuels, oils, and environmental energized. If some of these transformers start to arcing, you can have 2 different problems. That's if you start to be close, you don't have to be close because you can have this problem. See this fire, The transformers are arcing, but this is the problem of the transformer. Water for the deluge system, and see this. This is a ball of fire. If your firefighter is close of this, he will have a problem. We can hurt the firefighter, we can hurt the field responder, we can kill the field responder. This is why we have to understand that when we use this protection, we have to understand how can protect this facility. In the NFPA A50 say that the transformer fire protection is insufficient, and they start to understand that they don't focus on extinguish the fire. They try to prevent, spread the fire for the other transformer. This is why they start to put walls in the side of the transformer. They start to use different systems to contain the oil. But here in 2019, in 2010, we have two different fires on transformer in New York with the company Con Edison. In these two fires, the principal, the fire chief, they start to use foam, they start to use dry powder, they start to use purple K power, and they cannot extinguish the fire. One of the guys from hazmat team, they have one pail of A500 to use in the spills in New York. He arrived to the fire and he commented to the fire chief, "Hey, chief, I have this pail of this product. Can we use?" They spend 4 hours using water, foam, dry powder. Okay, we cannot extinguish. If we can, okay, we can use. A few minutes later, they extinguish the fire with only one pail of product, 20 liters. Yeah, the problem of this, that's the company, Con Edison, has a big problem about environmental, because with the quantity of foam that they spray, they kill a lot of fish of the river. Yeah, this is why 1 year later we have this test with the company Con Edison and with the fire department of New York. We use our agent. See the quantity of electric engineer here with the blue helmet, and a lot of firefighters testing how we can use different agents in environmental fires, environmental energized fires. Here, the problem of this is the conductivity leakage testing. This guy tests AAA foam, AR, AAA foam, and Encapsulator Technology. The test has to be less than 0.9 milliampere, because we, like human, begin to have some sensation at 1 milliampere. They start to conduct tests for 50 kilowatts. Any of the other agents pass the test. The only agent that passed the test about the conductivity leaking testing is the Encapsulator Technology. This is the test that they use. They use a fire nose, they use a monitor, they push a monitor on the top of the truck. And this is the test that they create a SOG, a suggested operation guideline, that when you use a pad of 30 gray, you have to be 25 feet. When you use a dead gun, a monitor, you have to have 125 feet of the fire. This is to prevent the conductivity with the people. It's for safety. Yeah? And this is a comparison in other fires. In 2016, we have the opportunity to be in a show, in a meeting with a safety manager of different companies of energy. One of the safety managers showed in the middle of this meeting a case history in Alabama Power. they show a video, a security video, that they show a transformer that it was arcing, and in the middle of the night explode, burn the transformer. You can see in the video that all the lights of the plant turn off, and you can see the flames. In a few minutes later, you don't see any flame. He commented in this meeting that the fire extinguished in 3 minutes, 10 seconds without any fire brigade or firefighters involved. Yes, when they arrived, the fire was extinguished, totally extinguished. They use only 3 gallons of A500, 100 gallons of solution. They don't have any cost of cleaning, see? But in the same company, because these two, Alabama Power and Duke Energy, is from Southern Company. 6 months later, they have other transformer fire, but they protect with a deluge system with water. Didn't work, didn't extinguish the fire, and 2 fire departments arrived to extinguish the fire, and 6 hours later, they can extinguish the fire with water. If the water didn't work, they use foam. They use 400 gallons of foam, 50,000 gallons of water. Do you know the agent, the cost of the agent was $8,000. Remember that we use $100 with Encapsulator Technology. But the problem that Duke Energy Company has to clean the 50,000 gallons of solution with foam and water because they contaminate off the ground. They have to pay $2 million to clean all these foam problems. You understand the difference? This is why in this moment, this company starts to understand, okay, we understand that we have a solution for 3-dimensional fire, that we don't need put in risk some of the fire brigade or some of the firefighter, because in this fire, 2 firefighters hurt in the middle of the fire. See? This is some conclusion of transformer fire protection, that the design sprinkler system based on NFPA A50 and A51 code. We can add with the same sprinkler system the encapsulator agent to the deluge system. We can extinguish 3-dimensional fire with a lower cost and less runoff. Less runoff you have, less problem you have to clean, less problem you have to spray all these different problems to the other plant. Yeah? This is some water application rates that we can use with water spray system in power plants with high voltage, 0.3 gallon per minute per square foot. And for turbines in 0.25 gallon per minute per square foot. C is 0.16 if using foam. Okay? This is when you start to understand that when you protect the transformer, when you protect a 3-dimensional fire, and you want to use a deluge system, you have to design like water. Yeah? You only have to add this technology and your system will be more effective. This is other solution for some company because they understand that the only solution is not use the fire, because if you have a problem with the transformer and blow up the fire protection, the sprinkler system, they have to have a second solution in hand. Can be this turbo cannon or can be this trailer, like Con Edison in New York have. Con Edison, with his fire brigade, they have this kind of trailer. They connect, the fire department arrive, they connect the truck to this trailer, and they only use A500 to extinguish transformer. With who? With the monitors, with distance. But if they have some problem with the fire, the sprinkler, or with the deluge system, they have a backup to extinguish this kind of fire. Okay? In different, in Bolivia, in Argentina, they start to put around the transformer, they start to put monitor with the encapsulator technology. They don't use a sprinkler system. They only use monitors to protect different transformers with this technology. This is an example of customers that they use in transformer fires. And this is the different solution that you can use for this kind of system on transformers, turbines, in critical cold handling system component. Here I can put in the power company, three-dimensional fire, lithium batteries, storage system. We can say solar panels. We can say inside of the aeolic system. And we can use portable delivery system like turbo cannon of trailers. And we can apply direct on transformer fire at 3% with nozzles. And remember that we test this more than 345 kilowatt. To finish, I want to say that this product is the unique category of fire suppression agent that you can encapsulate hydrocarbons, like the fuels, like the oils on the turbine and the oils on the transformer. You can reduce the heat, the capability of reduce the temperature is huge. And the most important thing for the fire responder, fire brigade, that you can decrease the toxicity of the smoke and the cancer-causing toxin for these firefighters. With the same agent, you are working to prevent, you are working to extinguish fire in the same token. The better thing that you can use only one agent to cool the metal in transformer and to encapsulate the oil. Here we have this kind of system because we have wheel equipments that if you have inside of a transformer, you have in a plant, you can move, you can connect the hose, and you can use this mobile huge fire extinguisher of 50 liters, 75, 100 liters, and you can have like a first attack more easy with this equipment. And here is the diamond doser that you can use and can be easy to connect, easy to maintain, easy to control. Remember that we can help you about consulting and training in different hazards that you need. If you have a sprinkler system to put, we can talk with our specialists all around the world that they can help you how you can use this technology with these different hazards. Okay, this is your time. Thank you for listening. I believe that you can understand very well my English, and we can open the microphone and you can put in the chats all the questions that you have. Mike, are you there?
Yes.
Okay. You understand very well the English?
Yes, the English was fine.
Okay. You want to make any comment, Mike, about all of this?
No, we're ready to answer questions if people want to ask questions.
Okay.
The only correction I might make is that when we were talking about the two transformer fires, one was Alabama Power and the other was Duke, and those are not both owned by the Southern Company. So Duke Power and the Southern Company are two different companies. And I think you had Corona ring, that they were both under the
same
umbrella of the Southern Company. No, Duke is a separate entity. So it just goes to show that in one place we have a fixed system with F500 and it's extinguished in 3 minutes and 10 seconds with no human interaction. The cleanup was negligible because they just pumped the solution out of the containment zone because there wasn't that much solution, ran it through the municipal wastewater treatment plant, pulled the gravel out, put new gravel in and put a new transformer in. They were up and running. I think the project you were talking about was another Southern Company project, which was in Georgia Power, and they had a fire and they used a bunch of Fire Aid 2000 foam on that. That was where a couple injuries occurred. They had about a $2 million environmental cleanup. And then the Duke was also another project, but again, the firefighters showed up with foam, sprayed 50,000 gallons of solution, took 6 hours to extinguish, and a huge environmental cleanup bill associated with that. So that's one of the big things. I think the only other thing I might like to add to the folks that are still here, let me pull it up because I might share my screen here in a minute, is you had mentioned aircraft hangars, and I think that based on some of the new standards, it might be worth showing a document. So I'm going to steal the screen here for a moment.
Yes.
I don't know if anybody can see my screen.
Yes.
Okay, so this is a document that was published by the National Fire Protection Association, NFPA Research Foundation, and shows a little background that NFPA 409 standard for aircraft hangar is historically, and then here until the 2022 edition. So we mentioned that the NFPA 18A is a 2022 edition just released in January. Well, guess what? 409, its new edition, was also just released in January. And up until the 2022, various fire protection options using foam systems. The requirement for foam fire protection, whether it was low expansion or high expansion, are largely based on some testing, a 900 square foot pool test conducted by FM Global in 1970. Okay, so that's where that came from. But under this research project, what they did was they involved literature review, current fire suppression applied to aircraft hangars, code revision, so on and so forth. So you get down here and they say, okay, it was found that there were very few fuel spills in aircraft hangars, only 25 in the last 5 years per the US Coast Guard, which has historically been viewed as the most likely fire scenario. So that's just the spills, 25 spills over 5 years, so about 5 a year. It says additionally, in the last 17 years, there were 44 foam system discharges in response to a fire, which averaged 2.6 per year, and 357 foam discharges where a fire is not present. So that's 21 per year discharged, for creating 7 million in damages a year. So boy, they're saying, wait a minute, we're getting about 2.5 fires a year, but with all the foam systems, with 357 foam discharges, and so we're getting 21 a year at $7 million a year, which does not include the environmental cleanup cost. So they're going, wait a minute, there has to be a better way than spending $7 million a year on faulty foam discharges. Now it says, in light of these, potential alternative fire protection solutions were evaluated. These included alternative firefighting foam formulas such as fluorine-free foam, compressed air foam systems, water sprinklers, water mist, and it says wetting agents, and right here, encapsulating agents. Okay, so the referencing, this report was completed and the new edition was released, which allows for alternate methods of hangar aircraft protection. I can tell you that several people on NFPA 409 technical committee have come to HCT to better understand the encapsulator agent, because they believe that is the solution and replacement for these foams. So if anybody does any aircraft hangar fire protection, I would encourage you to reach out to us, because we can shed a lot of light on the subject and how that could be designed.
Mike, could you display this information for us?
I'm sorry?
Could you send this information for us? This is very interesting.
Yeah. Oh, yes. I can send not only that information, but here is the actual final hangar report that talks about all the stuff, including wetting agents and different testing. And I think
very interesting.
When I say wetting agents, but encapsulating agents. I'm not sure why they put them together. Maybe because F500 is listed as a wetting agent under 18A until the under 18. So we were listed as 18 wetting agent, but while the development of 18A water additives has taken place. And so there they talk about it, encapsulator agents. So two totally different categories. And I think in Hernan's presentation, he showed 3 different categories of agents. 1, the wetting agent. 2, NFPA 11 foams, where they form bubbles to mechanically separate the fuel from the oxygen. And then NFPA 18A water additives, the spherical micelle technology, where we encapsulate the fuel molecules and separate the fuel from the oxygen on a chemical molecular level, as opposed to the foam that's a mechanical separation. So yeah, this information, we're getting ready to release that.
We had here a false discharge in American Airlines hangar in São Paulo International Airport, and there was inside a Boeing 777, and it was a mess. I've heard that all this mess cost around $2 million. I don't know.
Well, that's what that first article is saying. Yeah, 21 per year, $7 million, and again, that didn't include the environmental cleanup costs.
That's right. That's right.
So they're just kind of looking at property loss from aircraft and having to replace engines and things like that. So. Yeah.